I welcome to stage Laura from REM Tec. Thank you.
Hello, everyone. So thank you for the introduction. I'm happy to be here and show you experience in Agri-PV. One. There you go. Okay. So just a quick introduction on who we are, where we come from. So REM Tec is an Italian and French company. It's really a leading company in Agri-PV. Since we have developed our own solutions to combine agriculture and photovoltaics production. The company was founded in 2015, but the technology that we have included in the company and are developing now has its roots back in 2009 with the first patent filed worldwide, several countries around the world. So really we have more than 10 years of experience, and we have plants in operation with Agri-Voltaico technology for more than 10 years, and experience on more than 45 hectares. We are, as I said, have office in Italy and France, but we work all over the world. I know Miguel has given us a very good introduction of where we are at in the agrivoltaic market. What I want to add is that for us, for our idea, Agri-PV is not only the sharing of the land between agriculture and photovoltaics, but really it's an integration of the two worlds. So we do not have adapt an existing technology for agriculture, but we started to develop the technology thinking of the agricultural needs first, and to really create a synergy between the two worlds. So to give you an overview of what we offer on the market, we have several technologies, single axis, double axis, and fixed technologies. We have started in 2009 with the first patent with the Tracker 2.1, which really was based on an idea to have a low density shadow and created on the ground with a tracker structure 5 meter high and 10 PV modules mounted on a 12-meter tracker. After the first year of operation of this technology, we have seen that shadow can actually improve the agricultural yield and can be an help for the crop. So we started to develop a new release of tracker with a higher density of panels, and we have reached now to Tracker 2.1, which is the latest release of our dual axis tracker. The single axis tracker uses the same structure, but only moving one axis, which can be the main axis, but also the secondary axis. I will get into deeper detail later. These structures, this tracking structure, I think are really different from what we are used to see. So we do not have all the modules close to each other, but there is a space in between to leave light to reach the crop below the plant, and to give a really dynamic shadow produced on the ground. Then recently, just last year, we have introduced in the market a new Agrovoltaico family, which is a fixed system with PV modules mounted on suspended wire ropes. So the idea is to provide with a fixed solution to our clients, but also have a really large distance between the poles, which can go up to 25 meters, and a different panels distribution above the structure. So here just what we offer to our partners and clients. We can take care of design and give engineering support, but also we have internal agronomists that can provide agronomic analysis, technical support, and also maintenance and really deep R&D activity. Starting. Okay, so I thought to show you what what's been in operation for these past 10 years. What's better than to see it in live action. So here you see the trackers, which in this case are 4.5 meter high, are all connected to each other, and the rows of the trackers are distance. Can we maybe? So the tracker rows are placed 12-meter distance from each other, but this can be adapted to the agricultural needs. When agricultural machinery needs to work underneath the plant, the panels are placed in a flat position, so we have the entire height free for operating of the tractors. As I've said, then we have moved from that first technology to Tracker 2.1. Just to give some technical information about this, standard height of the structure and the poles is 4.5 meter, but this can be more. Let's say we arrive to 6 meter without many technical problems. The structure, the main tracker is, so this is the main axis of rotation, and it then has 4 secondary axes, which mounted a total of 24 PV modules. The PV module size is not fixed, so we can adapt the panel support based on the client requests and the PV module that it might be chosen. So there is a double rotation, as I've said before, and the trackers are mounted one next to each other and connected using wire ropes that are anchored on the soil at the perimeter. These really help with the resistance of the structure and lower the load on the foundation. So the impact on the ground is really low, and agricultural activity is not affected by this. The main thing that we manage with this kind of technology is the shadow. So the shadow is dynamic and can be controlled to reduce mainly the hydric stress on the crop underneath. So, for example, with the standard tracking that maximize energy production, we have also the maximum of shadow over the crop. But there are key phases of the growth of a crop, for example, flowering, where the plant needs a full light situation. And this could be a window of 5-7 days in spring, depends on the crop. And this window really helps the growth of the plant during the entire season. So with our system, we can choose to let's say sacrifice some part of energy production to leave full light to the plant, and this can, for example, for some cases, be the only way to agree with the farmer to have such a plant over an agricultural field. No, I'm going to back, sorry. So this is what I mean with shadow management. And this is really can be reached with the double axis system. With the single axis operation of the plant, we can find an intermediate solution, but the double axis is what gives us the most flexibility in this. And of course, it is also, let's say, compensate by the increase in production, in the energy production, of course. Then as for the fixed technology concerns, we have thought to develop a technology always based on a tensile structure. So we have these wire ropes that support the PV modules, which can be placed in different distributions. So this above is what we call the chessboard configuration, and this really reduce the impact of the shadow on the ground, because the shadow moves during the day and do not create like some rows which do not receive enough light during the day. The linear distribution is more similar to a typical PV system. And the choice between the two really depends on the agricultural needs and the impact that the shadow can have on the ground. What this solution also add to our technology portfolio is the possibility to be mounted on sloping surfaces. So while the tracker system has a limitation of 3% slope that can be tolerated, with the fixed system we can go up to 15% slope, but of course with the limitation of being like south-facing for the site. While another really advantage of the tracking solution is that we can place the row with almost any orientation, so we don't need to change the common practice of the farmer, and the farmer is more inclined to accept this kind of solution. So as I said, we have already some example. Some plants are running since more than 10 years. These are the 3 Italian plants built in 2011 with Tracker 1.0 technology. Here the ground coverage is around 14%. This is what we have mainly increased. The total power installed with the technology is 6.7 megawatt, and we also have operation of this plant in Italy, and this really gave us an advantage in studying the operation of this kind of plant and to conduct R&D activity both on the PV side of the technology, but also on the agricultural response of the crop. As I've said, we also operate around the world. After those first plants were built in Italy, there was really an obstacle in the national regulation, so the Italian market did not really develop up until the recent year, where we are starting to talk again about this technology. So we have expanded. We have gone to China, where through a licensee we have built a 444 kilowatt plant in 2016. Then we have moved with the new technology to France in 2019, building a plant with EDF. Always with through a licensee, we have built several plants in Japan. This is one example of 834 kilowatt peak plant with the new tracker. And then we are building in this autumn, with the EDF in the south of France, a prototype of the new fixed technology. So let's go in deeper details about the agriculture. We have seen up until now the PV side of the technology, but we also have, as I've said, a deeper look on the agricultural side and experience. So the first evaluation that we do when defining which technology to to install and develop is the impact on the shadow over the crop, and so the radiation reduction and how much the management of the shadow is needed. These are irradiation map, so it's they are calculated over a target area placed in the center of the plant that represents the behavior of the entire PV plant. So the size of the target area is defined by the distance between the row and the tracker length, or the span that we have between the poles for the fixed system. The fixed the fixed stripe agrovoltaico, as I've said, is more similar to a traditional fixed PV plant. That's where we have really static shadow on the ground, and the gradient of the radiation is really marked. With the chessboard configuration, we managed to have a more homogeneous irradiation on the ground, so we make sure that all the points of the ground receives enough light for the growth of the crop. And the tracker, let's say, it's an intermediate solution which gives us the advantage of managing the shadow and also to have a pretty homogeneous irradiation on the ground. So also here, I wanted to show you with a video what we are doing. This is one of the 3 Italian plants where we do most of our development and research directly on field. Traditionally, in our area, cereals are the most cultivated crop. But on this plant, we've also tried to do some research over vegetables. So we have tomatoes, potatoes, pumpkin, melons, beans, and salad. And we have studied the response of this crop under different shadow configurations. So both using Tracker 1.0, then in other areas with increased shadow using both shading nets and the prototype of the new solution 2.1, always having a control area in the full light zone to then be able to evaluate in the best way the results that we get under the field. So the research that we are doing started back in 2012 with the help of different partners. One of the main one was the University Cattolica of Piacenza, that has published a study on maize and the behavior that it has under different configuration of the agrovoltaico plant. So the simulation of the growth of the maize was done over a period of 39 years. And here we can see the red squares is the, I'm sorry, here it was changed. The red squares is the yield of the full light condition, while the gray square is and this line in particular, is the yield we get in under agrovoltaico. So even if in some years the results in full light are higher than below agrovoltaico, we can see that we have a stabilization of the crop production below agrovoltaico. This is mainly why we compensate the drought condition by reducing evapotranspiration of water from the soil. And this is really something that we are noticing now, that it's important to protect the crop from too much radiation and let's say to reduce the stress that the heat and the sun produces on the crop. As for our internal research is giving result. These are some key parameters that we measured under the Borgo Virgilio plant in Italy. So focusing on average soil humidity, we have that with the shading, we see a higher soil humidity compared to open field condition, and this is always thanks to the shadow and the reduction of evapotranspiration. Also, the temperature is lower, of course, under the shading than in open field, and this really reduces the stress on the leaf, which can be damaged by too much sun and too intense radiation. As for crop yield and water consumption, we also got some good results. Of course, this depends on the type of crop. There are some crops that better tolerate the shadow, and some other that are more affected by that. These are to be considered preliminary results because, of course, also the crop yield is affected by different parameters, mainly related to the weather. So we need several years of research to get final results. And what we also try to do is to analyze the same crop in different climate. So with the help of our partners, we harvest the same crop in Italy, in France, in Japan, so we can compare the results. And the reason for this is, of course, to validate a software platform that can predict the crop yield in response to weather condition and to agrovoltaico plant, let's say, technology and choice of technology. To come to this graph, salads was a really good crop to analyze, and we've got last 2020 results. We got plus 23%, 32% of in the diameter of the plant, and plus 40% for last year. This year results are still in analysis, so I couldn't include them in the presentation. Water consumption is also another parameter which is affected in a good way with the presence of the plant. We reduced water consumption for tomatoes of 30%, and up until 63% of water consumption reduction for pumpkins. Finally, another crop which is really interesting for the agrivoltaic sector is the grape. We have a lot of requests for plant over vineyards, and vineyards are one example of the need of the flowering phase that really needs full light in a weak period in spring. So we have measured 25% more production under agrovoltaico plant than in open field, and we have been producing for 2 years now also agrovoltaico wine for this little vineyard we have in the north of Italy, and we usually present it at the Intersolar exhibition. So if you will be there next year, we will be happy to let you try and taste our agrovoltaico wine. So this is more or less overall of what we do. Thank you.
Thank you. Thank you. Thank you. Thank you, Laura. Someday it will be turned on, but I can shout from my own. So, who's interested to know more about agrovoltaic wine or ask some other questions?
Thanks a lot, Laura, for the presentation. Can you hear me? Cool. Yeah, no, my question was about Italy, and you mentioned that things are moving now again. I was wondering if you could give us maybe a little bit more insights into what's happening and how you see, these new regulations and definitions moving the market forward? Are we going to see a gigawatt of agrivoltaic soon in Italy?
Yes, as you also mentioned before, only this year we got to the definition of guidelines to define what is agrivoltaic in Italy. Mainly they have divided by standard agrivoltaic, which also include harvesting between the rows of PV modules, so more sharing of the land that includes traditional ground-mounted system. But then they've also put emphasis on advanced agrivoltaic, which is elevated from the ground, and really also look at the monitoring of all the KPIs, not only of the PV plant, but the agricultural part. We are expecting in the December new tenders for state contribution to invest in this sector. We hope something will change in the sense to give more help to innovative solution and not with like traditional and already ready on the market, and so to help R&D and new development. And also another thing is that they are opening mainly to farmers or to energy company which cooperates with farmers. We hope that it will not like put a limitation, because of course farmers do not have a lot of possibilities to invest directly in this kind of plants. So this would limit the power capacity of this kind of plants. But we know that there might be some changes between the consultation phase and the actual publication, so we'll see soon. And definitely the interest in this sector in Italy is escalating now.
So congratulations. It seems that EDF is going rather towards your solutions. Total has chosen, as I understood, the next to sun approach, rather to go vertical installed. What I like about vertical is, for example, if you install it in more northern regions, like in Germany, where we have a lot of snow, that you have like no covering of the modules. You have like really, you don't have to clean it at all. And we are working also on vertical in Atacama Desert, and then cleaning is not necessary. I guess in your regions there's not so much snow, but what about dust? Can you combine like cleaning with watering of the crops, or is the cleaning necessary, or do you have some strategies how you move the panels? Okay.
Yes, so regarding snow, first of all, it's actually easy to manage for to the tracking solution, because you just put the tracker in an inclined position, so you let the snow fall down. And also for the cleaning, we've actually seen that there is a sort of self-cleaning of the modules when it rotates, let's say in the morning. So the moisture that that forms above the modules sort of clean automatically the module. For now, the cleaning can be done from the ground by rotating the modules in the higher position with brushes from the ground. We are also looking to develop like a robot solution that can run automatically over the tracker. So this is mostly that.
Or the SoliTek modules which have self-cleaning effect can be used. So keep in mind of that. Anyone else? Okay, thank you. Thank you for your presentation.